How to calculate the percentage purity of an iron tablet. So you'll be told in the question a certain amount of powdered vitamin tablet was dissolved in some water and sulfuric acid. The solution was titrated with a certain volume of a certain concentration of permanganate solution until a pale pink colour persisted. Calculate the percentage mass of the iron in the tablets, and you'll be told the chemical equation that shows you the stoichiometry, the ratio between the MnO4- and the Fe2+. So you do this in 4 steps. Step 1 is we're going to calculate the number of moles of permanganate that reacted. Step 2, we're going to calculate the number of moles of Fe2+ that reacted. We're then going to calculate in step 3 the mass of Fe2+ that reacted. And step 4, we're going to finish the question by calculating the percentage purity of the iron tablet. Step 1, calculate the number of moles of MnO4- that reacted. So we're going to use N equals Cv. So the number of moles is the concentration of the permanganate, which we're told on the question is 0.02, times by the volume, which is 12.10, divide the volume by 1,000 to put it into decimeters cubed, and that tells us the number of moles of permanganate that reacted is 2.42 times 10 to the minus 5. Step 2, calculate the number of moles of Fe2+ that reacted. So if we look at the chemical equation that we're given, 5 moles of Fe2+, that number 5, react with 1 mole of MnO4-. So we've worked out the number of moles of MnO4-, which is that number there. So to work out the number of moles of Fe2+, you have to times that number by 5. So 5 times the number of moles of MnO4- gives us 1.21 times 10 to the minus 4 moles. Step 3, calculate the mass of the Fe2+ that reacted. So to calculate the mass of something, you times the relative formula mass, or the relative atomic mass in this case, by the number of moles. We've worked out the number of moles as 1.21 times 10 to the minus 4. We get the mass of iron from the periodic table. So the mass of Fe2+ that reacted is 55.8 times 1.21 times 10 to the minus 4 gives us 6.75 times 10 to the minus 3 grams. Last but not least, calculate the percentage purity of the iron tablet. So we know how much iron there was in the iron tablet from step 3, 6.75 times 10 to the minus 3. We know the mass of the iron tablet from the question, it's the first part, 0.325. So the percentage purity is the mass of iron that was there, 6.75 times 10 to the minus 3, divided by the mass of the tablet, which is in the question, 0.325, times by 100, and the answer you get is 2.08%.